¿Me escucháis ahora? ¿Normal? ¿Hay que subirlo un poco? ¿Hay que subirlo más? Yo puedo hablar más alto, pero es un poco raro. Peter, tienes que subir tú un micro un poco. Hola, sí, 1, 2, probando. Hola, ¿ya me escucháis? Sí. ¿Mandamos más señal a la traducción? ¿Me escucháis? Más alto, por favor. Peter, ¿puedes subirlo tú un poco más? Ok, creo que lo mejor es que nos lo acerquemos un poquillo, yo creo. Sí, ok.
Friends, is everything okay with the translation? Yeah. Okay, I'm going to hand over to Kate and take it away.
Great. Thank you. Good morning. Can everyone hear me? Translation's okay? Yes? Okay. I'm Kate Sicchio. Since the last time I saw a lot of you, I've moved to Richmond. So that's one of the many big changes that's happened. This paper's rather short, and it's more of kind of an idea that still needs a lot of development, but I'm calling it Programming Paradigms for the Human Interpreter. And I'm really looking at this idea of the programming paradigm. This idea from computer science that there's different principles for different kinds of languages to support different kinds of problem solving. Paradigms may be considered exclusive, and languages may have multi-paradigm approaches. And then Van Roy says, well, if a taxonomy of language is useful, it has been debated. He's looking at paradigms. So today I'm going to look at paradigms where are either imperative or declarative, and look at how this is a potential framework for discussing how choreographic scores or rule-based performance might be interpreted by a person in performance. So this is a nice little diagram of different paradigms for computer programming languages. Yeah, so like the idea here is that it's not necessarily like one like it's not this binary between different paradigms. They're like quite a scale of different approaches. But yeah, sort of like you have more expressive or less expressive ideas. Some share different concepts in different ways, but it's kind of like this crazy map of languages. So I'm interested in the idea of the imperative. One way of describing imperative is that it's sort of commands and instructions on how to proceed. So statements of action, and then there's an outcome that's usually unknown. So C is usually thought of as imperative. Another paradigm I'm really interested in is declarative. So declarative is this idea of sort of definitions or relations that are described, and then that's what's computed rather than like step-by-step instruction. So shifting over to the other side of this is choreographic scores. And Jonathan Burrows, who's a British choreographer, in his choreographic handbook, wrote this about scores, that there's two approaches. One is a written representation of the piece, which holds the detail and linear time of what you will eventually see or hear. And the other is what is written or thought, or a tool for information and inspiration, which acts as a source of what you will see, whose shape may be very different from the final realization. And kind of similar to paradigms, he's saying these can be mixed. And another thing that he says is this can be written before, during, or after the piece. So sort of to like illustrate what he's saying here. So people always bring up Laba notation as a way of scoring dance. It's not done very often. It's really complex and I don't think it gives you a lot of information. And most choreographers don't have time to do this. So usually they'll hand you a video and say, you're the second from the left, learn it, rather than hand you a piece of paper with a formal score on it. But this is, over here, the majority of the score for an Yvonne Rainier piece called Chair Pillow. So these boxes all represent body parts, where they belong in space, and then it's over time. And you can see there's also still notes on the side. It's kind of impossible to really capture dance in this kind of way. And then probably no one here knows the dance Chair Pillow, but this is the accompanying music to Chair Pillow, River High, Mountain Deep by Ike and Tina Turner. Just to show you like this idea of the formalism of the score. But dance also has interpretive scores. So again, I've contrasted it with a music score. And then this is a Trisha Brown piece where I forget which piece this is actually. But it's a visual score, right? So this idea that dance scores don't have to be notation, just like music scores don't have to be notation. They can be much more interpretive. They might be speech, text, visuals, or in the case of the work I'm going to talk about, images. And many dance improvisation artists work from scores. So when you see a dance improv, it's rare that they just get up and do whatever movement they feel like. There's usually quite a set a way of exploring movement over time. And so you usually have these more interpretive scores for that. So this is Moving Patterns is a recent work of mine. I'm actually going to be performing it tomorrow as part of the conference. So this is actually sort of an example of the score that the dancer's using to improvise. So we are using photographs from a previous improvisation and then patterning them. So this piece has now been danced by, tomorrow will be the third dancer who's performed it. So it premiered last April with Ted Home, and then this is Marissa. She performed it in Richmond in October, and then tomorrow Phoebe Brown will be performing. And I'm just going to give you a little video of the Richmond performance. This particular performance is a little different than how it will be tomorrow because it was in a gallery space, so we actually had a couple different, a different setup than we normally do for the proscenium arch. But just to talk you through it, I am live coding these patterns of images to create the score in real time. And then Marissa is then using those images that are appearing in the space as a starting point for her movement exploration. There's my baby watching. So just like a little note on the technical side. So I'm live coding Untitled in a sort of extension that Tom Murphy wrote called Dance Dirt. So I can pattern the images in VLC player. So that's what's happening on the live coding side for the technical element, I guess. I guess the thing that I'm trying to tease out and that I'm interested in sort of exploring here, and definitely needs more thought around this, but this idea that, looking at this idea of the imperative paradigm, we can see that in sort of like the more dictated notations of dance score, right? So there's like really specific instructions, like where to put your body, how to do that over time. And there's like a real specific sort of result that we get from doing that. However, in my work, I'm more interested in maybe the different paradigms. So this idea of moving patterns, she's interpreting much more, and particularly as the piece progresses, and you'll see this tomorrow, she's getting less and less away from like matching the images, right? This idea that from one image to the other, there's like a pathway that she has to find to get from one place to the other, and that's not defined step by step anymore, right? So that the movement is what she has to come up with, right? There's these beginning and end points, and she has to find, and they have a relationship, and then she's determining that through movement. And that's sort of the exciting part of working with a human interpreter, is that they can do that differently every time. They have agency, so they start to like inject that into the piece. Some of the most exciting live-coded dance pieces I've done are when the dancer stops paying attention to the score. And even though that's frustrating as the person trying to create the score, it becomes much more interesting because there's something to like butt up against and and sort of play with there. So this idea that the amount of agency you give sort of a performer starts to determine sort of like what the paradigm of that score is, as a way of, sort of comparing and contrasting that with these computer science paradigms. This sort of patterning approach has become really of interest to me, but I'm not really, one of the things that's like become frustrating about live coding these performances is that I'm not using dance language when I'm coding, right? I'm like just kind of, in this case I'm using title, so I'm using that kind of, those actual sort of, I can't think of the word right now, but what I'm working on right now is actually creating a new mini language that instead of using the terminology of music, I'm using the terminology of choreography. Like, we would never say reverse, we say retrograde, small things like that. So then it's, instead of like live coding, like I'm trying to make a sound piece, I'll actually be typing instructions like I would be verbalizing to a dancer in the studio. And that's sort of the next place this is going. And that's it for now, so I'll take questions. Thank you.
Excellent timekeeping, thank you. Any questions to start? Yes.
On your last comment about making a language that specifically is informed by the terminology that you use in dance, would that language create the visual score that the performer would see, or would the language itself be the score? So in that case, would the human be the actual interpreter of the language that you're writing?
Yeah, right now it's going to pattern images, similar to what I'm doing now, but the idea is that it could be read just as is. And I've done a lot of work like that. I guess my first live coding stuff was all that. It was all pseudocode and people reading the code in the performance space. And what I kind of liked about those pieces was that they were pseudocode, so only a human interpreter could read them. So this is kind of, connected back to that, I guess, and that it could be a human interpreter or a computer interpreter making the final output, yeah.
Making you work.
Sorry, it's the usual thing. It's not really a question, but a comment. I was very struck by you saying that when you're coding, you're not using dance language. And I suddenly realized that when I'm making music, I'm not using very much musical language. I may have the word Phrygian or the name of a chord, but I can't put crotchets and quavers in. And I'm just going, ooh, can I have a live coding language that works in common practice notation, please? Thank you. If you could get on that, Alex, that'd be really great, thanks.
Okay.
This is nice.
I'm intrigued about the setup you have, and I just wondered how much the fixed position of the score affects how the dancer responds and performs with it. So there's a fixed projection in space.
Yeah, so 'cause we've done it in more of a proscenium space the first time with Teddy, and so yeah, that changes it a lot because they have to look at the screen, obviously. But what, particularly in the beginning of the piece, I purposely keep it quite slow to change so they can like look and respond and like look out to the audience and not have to spend their whole time with their back to the screen. As the piece progresses, it does speed up, and however, they're looking at it less anyways because they're sort of in a groove and doing their own thing and going away from the score and only coming back when they need it. But there is this thing about, using the screen in the space. And I've done this lots of different ways over the years. So I've had a setup where I've had just 4 monitors on the corners of the stage and no projection. I've had a setup where the score was on the floor. These are, all different pieces I've done over the years. There was my haptics piece that I did at the first ICLC in Leeds, so the dancer felt the score as vibrations as I was live coding it. I've kind of explored this a lot of different ways. It's problematic to use the screen. It's also easier to tour with.
Hi, I'm here. I'm following on the first question you received. So the question is, why did you feel the need to move from pseudocode to real code? In other words, yes, the pseudocode is for having a human interpreter, but then moving to real code, what do you want the computer to interpret?
Yeah, I think there's a lot more possibilities in terms of like what computing can bring to this. So like randomizations or different possible combinations, or there is something interesting about the computer as a tool in this that brings new ideas and new like places that maybe I wouldn't go if as a human, I have habits, right? So I'm gonna probably, it's an improv for me, not just the dancer, right? So I'm gonna have things that I keep going back to, right? And the computer can break those up and make new possibilities and new sort of pathways for movement. So that's like one of the reasons to bring the computer back into it, is to find things that I wouldn't have thought of while making the score.
I really like your approach to declarative versus imperative, which, as you were pointed out, is often talked about in terms of, if I get this right, declarative is talked about in terms of saying what you want to do, and imperative in terms of how. But it's always struck me that for music and choreography and everything else, how you do something is really part of what you do. And so I think it's really nice to give agency to the interpreter, because then what they do is, I suppose the idea is that how you do something isn't important in computing, but that's not true in choreography, is it?
Right, no, it's definitely important.
Yeah, and I think that's true in general, so it's nice, I think we should move on to Anne, so thank you very much, Kate. Round of applause.
Good morning, everybody. It's nice to see you. I'm sorry I haven't really been around the first day, but hopefully we'll see more of everybody in the coming days. I'm going to be presenting my paper one player, two instruments. And unusually for me, it actually doesn't talk about my own practice at all. In fact, I discuss other people's work. So here we go. With the rise of more user-friendly music technologies and the accessibility of these tools, more acoustic instrumentalists explore the world of live electronics in relation to their own instrumental practice. These range from working with effect boxes, digital or analog, to the use of hybrid extended instruments, to performing with autonomous improvisatory systems, or a variation combination of the above. The use of live coding in combination with one's own instrumental performance is not excluded from this movement, although it is less prevalent. Over the years, various performers have included interface duality in their sets, but unfortunately many of these are not well documented, and consequently cannot be discussed. It is not my goal in this talk to present an exhaustive list of everyone that's done this. I'm just going to focus on 3 case studies, which are primarily chosen for the accessibility and the documentation, and also for the diversity in instrumental use. Oh, it worked. Okay, so 3 case studies I will talk about will be Xavier Riley's Don't Drop the Bass, Alexandra Cardenas's Feed Forward, and Nick Collins's Robot Schumann. Some of you that have been going to the live coding events would have seen these throughout over the years. I will give an analysis of these 3 case studies in terms of time dedicated to each interface, sounding outcome, and the act of transitioning from one interface to another. At the conclusion of this talk, if there is time, there will be a reflection on the case studies and a discussion of alternative modes of instrument duality within instrumental and live coded practices simultaneously. So Riley's Don't Drop That Bass was performed at the 2017 Brighton Ruby conference. Riley's using Sonic Pi, and he set out to perform this to show the new features, the new Midi features of the period, which support instrumental and Midi input. The performance only lasts 5.5 minutes, which I think you will find is quite short for a live coder performance. And I'll just play a very short example to see how he interacts with it. Ooh. Oh, where did it go? Oh no. Okay. For those that missed it, did you notice how he did his little pray symbol before and they're like, yes, it worked? I think pretty theatrical. I'm pretty sure Riley is a very competent programmer, so setting something like that up in Sonic Pi wouldn't have been a huge challenge, but I think he did it expressly to show the theatricality. Look, no hands, and to show that it's working. And he kind of continues in this pattern throughout, moving between playing and coding. So if you do a breakdown of his piece, and I got asked to speak slower, which is not my forte, but I'm going to try. He's essentially going from coding to playing to coding to playing. And generally, I would say that the coding is leading the performative narrative, and the bass is serving as input. Besides the percussion beat at the very beginning, the sounds are primarily all focused on the bass, and he's dealing with the samples through manipulation. The coding is done essentially from a blank page. In the video, there's like one bit of code already written, which is the tick, tick, and it could be that even that was done on a blank stage, but the video crew didn't tape it from that moment. So what he's doing is he has this blank slate approach, which I think ties really nicely to the top left manifesto of give us access to performance mind, because you really see the process unfolding, and he's really sharing that. From my little, oh, you cannot see it. Okay, guys, never use speaker notes in Google and try to play videos at the same time. Oh. There it is. Yes. Okay. Sorry about that. So you can see that at one point, from around 318, he starts kind of focusing more on the playing. And then he's really kind of playing and coding interspersedly. No, what have I done? Okay, okay, okay. When I watched this, for me, it seemed that most of his code was premeditated, and he had a very clear idea of what he wanted to do. But there is one point at the end where he seems to kind of be trying to fix something. And but I think that's a really interesting point, because it's the first time that he's really playing and coding simultaneously and moving between the two interfaces very quickly. So fortunately, that means that I have to go and play this, which is going to be, again, sliding back and forth. So he never really misses a beat. So even though you see that he's like going back and maybe a little insecure, it doesn't really lose any musical flow. And I think that's really admirable, because it's, as those of you who have tried to fix something whilst doing something else, it can be quite challenging. Okay. The other thing that was really good about his performance, sorry, last point, is that the screen is huge, which gives it a very nice equal presence as the performer. In fact, the performer is almost too small in relation to the screen, but it gives this nice balance to the performance. Okay, I think everybody here knows Alexandra, so it's nice to be able to discuss one of her earlier pieces. So Gardanas performed Feed Forward at the 2015 International Conference on Live Coding in Leeds, the first one. In her performance, she uses a combination of her electric guitar and Ixi-Lang, making much use of Ixi-Lang's autocode function. And the performance lasts around 11 minutes. The work opens with a layer of distorted sound produced by the electric guitar, which is fed into Ixi-Lang. Once the autocode function is launched, the performance unfolds as an improvisation between the performer and the laptop. As Cardenas describes, the performance is an interaction of pre-existent code with newborn code, or of pre-existent sounds and newborn sounds. And I'll play a short extract. Essentially setting up the Ixi-Lang, and then later on she's just... And Ixi is coding on its own. These are all available, so I highly recommend you guys go check them out on your own. this is more or less a rundown. Very few actual switching between coding and playing. In this performance, the guitar is clearly leading the performative narrative, and Kaidanas is only minimally engaging with the coding. Instead, by engaging the generative autocode function, she has eliminated the need to engage with the laptop herself while still keeping the code live. This connects her performance to the broader field of performers interacting with generative systems. However, an advantage of ICLC's autocode is the transparency of its generated code, which allows it to be just as easily followed by audience members as human-coded ICLC code. The sounds and feed forward are all derived from the guitar input, with autocode applying a variety of effects, transformations, and manipulations. Kaidanas uses a range of extended techniques on the guitar, which is lying flat on the table for the duration of the concert. This assists in creating an electroacoustic noise style performance. Finally, I'm going to talk about Nick Collins's robot Schumann. This is the first time I actually saw someone playing a piano and coding at the same time. It goes back all the way to 2013 at the Live Code Festival in Karlsruhe. Collins uses Super Collider to live code a disc clavier, which is a mechanical piano, if people don't know, which can be engaged with Midi. And he also uses a text narrative and plays the disc clavier himself. The performance lasts just under 8 minutes. This is primarily a live-coded performance with a strong theatrical component. Schumann's symphonic etudes opus 13 are used as a source for pitch and time structures, which are then manipulated through live coding intervention. Alongside coding the disc clavier, Collins launches a text writer which prints a letter for every note played on the disc clavier. The text unfolds as a humorous biographical story, and Collins also calls a number of Schubert-related images, or not just Schubert-related images. So there's a few more playing and coding than by feed forward, but also not nearly as many as Riley had in his. The proportion of piano playing to coding is leaning greatly towards the coding. However, because the coding is also playing the disc clavier, there's a great unity between the two actions. Much like the code controlling the disc clavier, Collins also plays extracts of Schumann's symphonic etudes, but in their original form. This gives his playing a distinct sound, one of romantic piano performance, which contrasts the more mechanical output of the disc clavier, but shows the two as being distinctly related. Furthermore, Collins codes whilst in a half-standing position, where a pianist usually sits, and this visually binds the audience's perception of whether he is playing or coding. We don't have time to play the video, so I'm not going to do it. And apparently I skipped that slide anyway. Okay. So finally, to summarize. The transparency of the code and the clear artistic ideas behind these case studies gave them strength as successful performances, at least in my opinion. The works share the presence of only one main audio source, or sonic plane, which undergoes a series of manipulations by the live coding. Where Riley played both his bass and coded a relatively similar amount of time, Kaidanas and Collins clearly favored one instrument over the other in their performances. However, their choices were compensated for by the presence of autocode continuing the live coding and the disc clavier playing the piano from the live coded parts. This compensation also meant that the practice of live coding and instrumental playing were engaged throughout the performances, albeit not by them. This is certainly something that could be applied in other one-player, two-instrument setups. For example, I've been working with Andrew Brown's Ripple system, where Ripples generates a musical jet partner which learns from the live piano input to create related piano output, essentially continuing on from where the pianist left off. And by doing this, I can quickly try and code in Sonic Pi. And of course, there's the choice of skipping the two instruments and having one instrument that allows you to live code and play the piano like we've been doing with our Code Clavier project. I think when you really do choose to have a setup of two instruments, then you are choosing for something that has to be theatrical, because there's nothing comfortable in this idea that you are playing here and playing there. So there's theater anyway in it, so embracing the theatrical side of it is a way to strengthen the performance. And finally, I think there's a lot of physical challenges, but the biggest challenge of playing and coding simultaneously is the cognitive one, because your brain has to think like, whoa, about 2 different things at the same time and try to continue the musical flow. So thank you for having me.
Any questions? Yes, Craig.
Craig? Oh, sorry. I'm a pianist, so I should have said that at the beginning.
Hello? Oh, I had just asked what instruments she was considering incorporating into her performances.
Yeah.
Yeah.
And I said I'm a pianist. And yeah, so most people, I should have started with that. And the piano is actually uniquely suitable to playing and coding concurrently, because you could still, I've tried this, it's very possible at a very slow and calm tempo, play with one hand and code with the other. But when I do this, I've noticed it's a very similar practice to what I do with the code clavier, which is try to keep something going here and then code with my right hand. It's possible, but it's a very slow process. In fact, I did this as a reason, because I do a PhD, to say why I need to have the code clavier.
May I ask another question? What strategies or tactics do you have in mind for ameliorating the cognitive load of doing 2 things at once?
So this actually, again, talks about code clavier. Basically, when you start feeling comfortable with the physical action, for me, it's about learning the physical action of the coding and making that, learning the cognitive coding and making that a physical action. So you bring it to the same plane. And taking time, you just need to take time. And you get better at keeping something going. I mean, I've been training to keep my hands doing separate things for a long time. And even with now with the code clavier, I realize how bad I am at it. So it's every step. If you listen to a really early video of ours, you can tell that I'm like really typing like this, whereas now I could do much more in the left hand or the right hand, whilst the other hand is doing coding of some sort.
Thanks, Anne. I wonder if you could comment a little bit on the things you're looking at here in relation to adjacent situations like duos. You know, we've just been talking about cognitive load, and certainly one of the really common ways of managing cognitive load is to get someone else to help you.
Yeah, so you should. I mean, that's why I say I think you cannot say that this is not theatrical. If you're setting yourself up for something as challenging as playing and coding simultaneously, then you're doing it to show, look at me, I can play and code simultaneously. Like, it is a theatrical and a very kind of virtuosic for unnecessary reason statement. Of course, someone that's going to be coding and next to someone that's playing an instrument, they're going to make much more interesting stuff. But it's very amusing. You know, we've had this tradition of one-man bands since, like, the early ages.
I was actually going to comment on something similar to that, just thinking about the relationship between live coding and live looping. Live looping, performers that do real-time composition through looping themselves, maybe playing different instruments. I was wondering if you had any thoughts on the relationship between those 2 practices.
Well, I kind of touched upon it at the beginning, yeah. So it's just that normally those people just have foot pedals. Yeah. And sometimes they can look pretty clumsy when they do it. Actually, a lot of the time I find it quite clumsy. But it's just part of the practice, I guess. And you can get better at it, because with looping you have to be very precise when you press that pedal, so it kind of becomes rhythmical. Some people think that live electronics should be like magic. You know, there's this idea of not to be seen. It should be like, whoa, and then it happens. And then I think when you say, especially when you go for live coding, it's the opposite. It's not about magic. It's about, now I'm doing this, check it out. I'm thinking about this. Oh, shit, this didn't work. I'm going to try again. And so that's kind of a statement difference, I think, in your approach.
Mine's just a comment. It's not really a question. It's quick. I was thinking about the two-handed sort of performing two things at once.
Okay.
And just a comment that a few years, I mean, it's still in development, but there's an application for the phone called AUMI. It's AUMI or something, and it's an augmented musical interface for using eyes to perform music. So it might be another way to have both hands perform on the piano and then use your eyes with some other, I don't know, interface for being able to program. That's all, just a comment.
I wonder, though, if the cognitive challenges will remain with something like that. I think I also saw maybe I saw the same project or someone where they really like put things to get the brain waves from your brain, and then you were making music through that. So there's a lot of research being done into that. So I think especially for people that don't have good mobility, to be able to be curious to see how that pans out. Yeah? Oh, one more.
Hi.
Hi.
I was thinking about the thing you said about playing with one hand the piano and with the other hand coding. And I was wondering whether you considered, or if anybody has done it before, coding with a stenograph.
With a stenograph?
Yeah, which has a, you know...
Yeah, so actually last ICLC, Jack Armitage was talking about live coding, and not just live coding, live chording with a stenograph. But when I met up with Jack in July, and he's like, yeah, I'm too busy doing other things at the moment. I haven't seen it being done, but the stenograph is certainly an interface that's being explored as an alternative to the traditional keyboard.
Yeah, and exactly. Yeah.
Yeah.
Thanks, Alex. Thanks to everyone who's organised this conference. It's a huge honour to be here. I'm Jack from New Zealand. I'm a master's student, and today I'm presenting my paper, CJing practice, combining live coding and VJing. So this paper proposes the definition of a hybrid performance practice that we call CJing, or code jockey practice. The paper also introduces a new tool for live coding visuals that we've developed to illustrate this CJing practice. Some of the images here are some of my work, outputs of the tool that I've used during performance. So what is this CJing practice? In CJing, the performer is known as a code jockey, and their role is to improvise, manipulate, and composite code to generate graphics. So CJing aims to solve some issues we've identified in two performance practices. The first being live coding. And we believe there's an issue here with live coding has this reliance on typing text. And this impairs the usability of the practice during live performance. An example where this is the case is, say, you need to update a parameter. This needs to be done by explicitly writing some code to set that value to a discrete value. And this doesn't really offer good exploration of the parameter space. So while you could write some code to perhaps animate that parameter, that can also take some time. So the second performance practice is VJing. Does everyone here know what VJing is? Yep. So the DJ version of doing visuals. And so the issue with VJing is there's a lack of fine-grained content control. And what we mean by that is that they have a reliance on using pre-rendered content, such as videos, which you can't manipulate at a low level. And while some software supports procedurally generated graphics, the coding aspect is almost never a priority in these applications. So CJing combines live coding and VJing practice to solve these issues simultaneously. And the reasons for this is live coding can benefit from VJing by incorporating useful user interfaces and methods of interaction, such as the use of hardware controllers that are commonplace in VJ practice. to allow for interaction with code. And VJing can benefit from live coding due to live coding's ability to create and manipulate content at a low level using code, allowing for fine-grained content control. Closer? Yeah, great. So to illustrate CJing, we've developed a new tool called Visor, which is popped up here, which I'll now describe in detail before coming back to discuss CJing in detail. So Visor is a new live coding environment for real-time visual performance. Visor bridges the gap between creative coding and VJing by offering user interfaces to easily interact with live coded processing sketches. Visor offers a simple API for mapping visuals to audio or Midi controllers, and it achieves this all in the expressive Ruby programming language. And this is actually what I was performing with last night at the Algo Rave. So we had a number of goals when we were developing Visor. The first one being to illustrate this CJing practice, to create audio-reactive visuals easily, allow for interactivity with the code. Usability, this is a big one. We achieve this by providing a simple API for the performer, less boilerplate, the better, and we also provide user interfaces to allow to assist the performer in their performance. And also, importantly, we want to empower the use of the processing language for live performance. So more concretely, these are the features of Visor. So the first one being live coding of processing in the Ruby language. Second being state management. And what I mean by this is the ability to inspect and interact with state that you've programmed into your code. Support for MIDI controllers for interaction. FFT and tap tempo, these are audio-reactive features, also seen in VJing practice. And layers, so ability to easily organize and compose content. So now I'm going to show a demo of Visor to demonstrate these features. I should note that software's come a little bit further since I submitted the paper, so a few things are a little bit different. One moment. Hopefully you can see this. So this is Visor here on the left, and this is the processing output window here on the right. So I mentioned that we can live code processing. So here we have a simple sketch that's drawing a rectangle on the screen. This is all live, so I can change things like the background color, or perhaps the size of this rectangle, all very easily. So that's that. The next thing is the state management. So what I mean by this is the ability to define some kind of state variable. So for example, maybe I'm going to make the color green. Hopefully you can see that. I'm going to set that to some initial value, maybe 50. And what you'll notice is that it's automatically appeared in this interface here, where I can actually interact with it, and I'm manipulating that state automatically. And you can see here that there's some kind of contextual user interface for this. So obviously it's detected that it's an integer, so it's given me a range. So I could actually just set the range here. Now I'm iterating, well, moving between 0 and 255. And now I can insert that into my code. And now I'm changing the color of the rectangle. So I set the range using the interface, but there's also like methods for doing this in the code. So I could use the set range method. So it's important that you can kind of do it with the interface or with the code. But importantly, there's this relationship between the code and the interfaces. So the next feature I was going to show is the FFT. So you'll notice that it's being visualized down here, which we believe is really useful for identifying like important information in the sound, so you can create reactive visuals to that. So I can just drop that in here. Looks like here's quite interesting, 12 to 14. And now animating as I talk. Other features, the tap tempo. So this is kind of a way of doing kind of beat detection without the analysis, which can sometimes be unreliable. So you can essentially use a keyboard shortcut or tap in the interface to set a tempo, and then I can access the information that that interface is providing in the code. So for example, beat progress, and now I'm animating to that. So just imagine the pounding techno, and we're good. So the next thing is interaction with controllers such as Midi. So I've already set this up here with like a mapping, but essentially it's meant to be as easy as just dropping a variable into the code. So for example, S1 here refers to the first slider on my controller, so I can chuck that in and arrow away. And you can also attach things to Midi through the interface. So here, once again, another contextual interface that shows me the variables on the Midi controller. Boom. Nice and easy. So the next feature is the layers. So I've already set up a nice particle system here, which I'm just going to chuck in. And you can see here that we're looking at the state of the particles, not so useful, but I've got some other parameters here, such as the radius of them and the speed. So the cool thing about layers is it's a good way to kind of break up parts of your code. You can also use different effects. So I could subtract here, if I make that a bit bigger. Or multiply, for example. So this is just building on features that already exist in processing, but trying to make it as easy as possible to do during performance. So that's Visor. I'll head back to the presentation now. Great. So next I'm going to talk a bit about the related work. So there's a number of different systems that kind of have similar features to Visor or demonstrate ideas of the CJing practice. The first being Praxis Live, which allows for live coding of processing in Java, and it also demonstrates use of user interfaces that abstract upon the code. You do that with the node graphs, and also has visualizations of state. So while Visor doesn't support visual programming, it aims to have a simplistic interface that places emphasis on live coding, processing, audio-visual performance. Another one is Sonic Pi, provides live coding in Ruby as well, but also Sonic Pi has a really low barrier to entry, tries to make it as simple as possible, and we want to do that with Visor as well. Code Life, GLSL, shader programming, live coding. Shader programming is great, because you have very nice outputs, but we believe it has a very high barrier to entry. So Visor trades this complexity for usability by making use of processing to lower that barrier. But there's no reason why you couldn't live code shaders in Visor in the future. And lastly, we have Mother, which is a processing library to enable VJing of multiple sketches. And it kind of acts as a middleware between things and uses OSC to communicate. But instead, Visor brings this into the same application where sketches just resolve themselves in different layers. So next I'm going to talk a bit more about CJing and its background and what it actually means for a piece of software to demonstrate CJing ideas. So this is kind of the diagram that describes where CJing arises from. And you'll see that it's at the intersection of three topics, so being live programming, creative coding, and VJing. So you can think of some different examples of software that you might find in these different areas, such as Resolume or VDMX for VJing, processing for creative coding, perhaps Lighttable for live programming. So we believe Visor presents itself in the center of this diagram, and perhaps some other live coding tools do as well. But based on these topics, we can kind of see that CJing is this usage of live programming techniques to enhance creative coding, as seen by live coding. But specifically looking at how VJing interacts with that in terms of user interfaces and methods of interaction to try and enhance live coding for live performance. So CJing. So we propose that CJing practice is possible with software if it demonstrates three key ideas. So the first one is user interfaces as an abstraction. And what we mean by this is this ability for a program to analyze your code as you're writing it or executing it and provide contextual interfaces to visualize the state of the program, allow the programmer to inspect it and interact with it. And We see this in Visor, for example, by its ability to interact with state as it's defined, and it can be edited in the interface without having to go and write code to explicitly set the value of parameters, for example. But it's important to note that CJing software should attempt to abstract upon live code and supplement the program rather than replacing or implementing unique behavior that renders live code obsolete. Because there's some examples of some user interface heavy systems which do support coded elements, but that's more of an afterthought. So we want to make sure that code is still really prominent here. The second idea is complete content control. And what we mean by this is the ability to edit any part of the final output. And CJing achieves this by combining live coding and VJing, because live coding allows for low-level editing of individual parts of the program through coding, while VJing allows for high-level editing of overall parts of the final output through user interfaces. So for example, in Visor, we can see this by, at a low level, you can edit your processing sketches to define the content of the final output, but at a high level, you can manipulate layers of coded content that kind of helps you orchestrate the final output. So being able to edit content at a low level and a high level makes a CJing system very flexible. So this last idea is code as universal language. And by this we mean that content should be generated primarily based on algorithms and code. So if a DJ mixes music and a VJ mixes video clips, then a CJ should probably mix code. There's a good opportunity here for like an ecosystem of code to be made where things are shared, and this is common in the VJ community with video loops and images and other assets. So why can't we do the same with code, I suppose? But there's also no reason why CJing systems can't use these assets like video clips and images. So next, I'm just going to touch on a couple of discussion points that have arisen from this research. So we're done. Sweet, I'll just conclude, yeah. So, in conclusion, I've defined this new practice called CJing, created Visor, a new live coding environment that demonstrates that. I encourage you all to check it out, download it. This is part of my master's research, so there's a feedback survey, so I'd really appreciate if you got involved with that. And I'm also going to be running some more in-depth user evaluations, so if you're keen on processing and live performance, then come and talk to me and we can perhaps book a time for that. Thank you.
Sorry to cut you short. Yeah, any questions for Jack? Okay.
Now it's working.
Just a question in relation to the Visor. In DJ and VJ tools, generally you have a crossfade between things. Does it do Visor the same across multiple, for example, processing sketches?
Mm-hmm. So you could easily map like a slider to your layer opacity. So Visor provides, I suppose, like internal state of these constructs that it has, like layers. So you can easily map to that and fade between different layers.
Good. Thanks.
Do you find it important for you to set up the controller beforehand and make sure that it stays relatively the same so that you know sort of by muscle memory where to go and what to reach for? Or do you find yourself remapping it in real time and changing what controls what?
So it's an interesting question. So normally I'm mapping to it as I'm performing. So you'll be defining these, if I'm starting from scratch, you'll be live coding a system and you'll start to inject these different parameters. So it can get a bit crazy because you've got to remember where everything is. But for the most part, it works pretty well.
I guess this is fairly similar to the previous question. Having watched your performance last night, can you speak a little bit about sort of your process combining both the interface and the programming itself? So as you're using it, how do you feel like you have this balance between sort of a VJ practice and this coding practice together?
So the balance is an interesting thing because when you're actually using the controller, you can be very expressive and reactive to changes in the music. So you can make some very cool effects. But the moment you switch back to the coding, suddenly that level of interaction is kind of lost. So balancing that is difficult. But of course, there's still things you can do with the live code to be reactive, execute things at the right time and stuff like that. But it's definitely a challenge, if that answers.
One at the front.
In some VJ software, VJs use some type of objects as blocks with a timeline. And have you aware of, for example, have a timeline or code blocks so that you could like use a sequence and so.
Could you do something like that? Is
yes,
that what you're asking?
Something like that.
Not in Visor at the moment, but these are the kind of features that I would like to see more incorporated with these kind of systems because they have a lot of like ability and a lot of power, and like VJs use them professionally. So can we integrate these features with live code? And that's what I'm trying to show with like the tap tempo and the layers. They're really powerful features, but they require some kind of additional user interface on top of typing text. So that's the kind of thing that I'd like to see more of as well. Jen?
Yeah, I guess I just want to ask about this word CJing. I couldn't see any difference between CJing and live coding, at least as we use the phrase in this conference. So do you see it as a way of talking about your own practice? I just couldn't quite see the difference, what this new word brings to the field.
Yeah, so this is one of the discussion points. I guess it's why do we need to make this distinction between live coding and CJing? And the kind of reason for that is, I guess if you look at the manifesto, live coding is very predominantly focused on this typing stuff. Or maybe it isn't. So maybe CJing doesn't need to be its own thing. But there are aspects of CJing that kind of are different to live coding or detract from it. So for example, now that we have a more complex user interface, it's perhaps not as easy to communicate the whole process to the audience. We can't just project the code. Well, we could, but it's still not showing the complete representation of what the performer's doing. And we get these MIDI controller things, which is great, because it's visible interaction. So it's kind of, this question is, does it deserve to be its own thing if it's bringing in these other interfaces? Or perhaps can we allow it to be integrated as part of common live coding practice? It's definitely a question.
Right, thank you very much. I think we've got one more talk, but would anyone like to give? Here we go. Right.
think it's fine. Thanks. A ver, vamos a hacer menos una prueba. No, porque eso es muy complejo. Falta menos 15 minutos y no funciona. Ok. Una vez más. Vamos a esperar que... ¿Sí? Así, no sé qué pasa. Ok. Pues empezamos así. Hi, my name is Luis. We're going to, and this is Marianne, Ivanka, and David. We're going to present our paper that's called Bellacode, Localized Textual Interfaces for Light Coding Music. And we wanted to make, we wanted to start with a small performance, but we have some technical issues that we hope to solve soon. I think it's ready. Yeah, so there it is. Okay, so yeah, so I think that's going to go for forever. So this is our first performance with these languages. We're still learning how to use them. So our talk, we're going to hurry up. It's about these languages and about some workshops that myself and the members here in the panel, we were giving in South America in May. And so we're going to talk more about these languages. So briefly, we're going to talk about the context and motivation of this paper and these languages, as well as the workshops in which these languages were made. We're going to talk about the methodology for the workshops and for developing these languages. And we will talk about the logic behind these languages, particularly these two that we were performing with, that it's called La Calle, and the other one is called SUSI-X. And finally, we have a conclusion.
This paper, también surge un poco como de la problematización sobre el lenguaje y, bueno, como también un poco como el reconocimiento de comunidades de live coders en Latinoamérica y, bueno, también como plantear la cuestión de como del idioma natural y como la forma en la que el código se escribe, que generalmente pues es en inglés, ¿no? Entonces como que fue un intento de desplazamiento del inglés como un idioma para crear sonido con código en vivo.
So the context and motivation. Yes, can you? So we were saying that. Just a sec. I need my notes here. Okay, so these languages, La Calle and SUSI-X, as well as this paper that we're presenting today, are the results of a series of workshops that we taught in May in 2018 in different institutions and cultural centers in South America. These workshops were motivated by my ongoing PhD research at McMaster University. David is my supervisor, and the research is about developing culturally situated platforms for live coding music. So in these workshops, we were, this was the first approach for me, in the sense that I was looking for different linguistic and functional logics around programming languages, and different in the sense than the ones that are already established. Basically, I was looking for programming languages that could be made in a different language than English, because English right now, it works as a global tongue for software. So I was looking to other potential languages, natural languages in which programming languages could be made. And the other one was looking for functionalities different than the ones that we have. And that's also part of the future work. And secondly, the motivation for these workshops was to build community in Latin America, look for communities of live coders in Latin America. So during these workshops, we encourage participants to develop their live coding languages using their own linguistic logic. And from this, we encountered two problems. One was that many of them, or many of the participants were having found problematic to have a lingua franca of software, which in this case could be English. And the second problem we found that was, maybe this was not a problem, but was more a desire for the participants to see their own language reflected on mainstream live coding languages. So these are the pictures of how they were developing these languages. They were developing them in paper, so designing them in paper, designing the logic.
Yeah. On the workshops,
the
participants make only the design of the languages. We make the translate on the, Luis make the translate from language of the machine.
Yes, so to make these languages in a more technical part, we were using, we were just parsing, which means that we were taking a language and translating, or some syntax and a dictionary, and translating that into another language. So for developing these languages, we used Estuary. That is a collaborative web-based live coding environment. This one that in which we were performing today, developed by David Ogborn and others. And then, and also we were making these languages around the affordances of tidal cycles. The reason for this was that the features of Estuary provided participants, or enabled participants to work immediately in the browser rather than installing software, and to testing and playing with their developed languages right away, either in solo or in collaborative setting, and also because we used tidal cycles because this is already programming language and has an infrastructure around which we were wrapping these custom languages. So we were using tidal cycles infrastructure and functions, and the sampling engine that is used in Estuary, which is called WebDirt, which runs the samples, allows to run the sound and the samples of tidal cycles in the web. So during the workshops, participants had the option to adapt, translate, and customize tidal cycles, lexicon, syntax, sample files, and functions to their specific locale or culture, not only to make them more meaningful and comprehensible for them, but also to potentially convey specific cultural and political message about code itself. So we place these languages in the category of localized live coding languages, live coding esoteric languages. And I want to briefly mention some of the goals of esoteric languages, and which was our particular goal. So esoteric languages, or ESO-langs, such as, well, in the paper we give the example of brain fog. So they often deploy opaque notations in order to uncover the constraints of mainstream programming languages, so the limits of programming languages. Another purpose of ESOLangs is that they propose alternative programming notations in order to highlight the expressive possibilities of computer programming. And finally, our purpose and how we see ESOLangs in this particular case is that, again, we were inviting participants to explore or convey a specific cultural and political message about code itself. So, and particularly, I think this makes sense in live coding because we usually we share our screens with the audience, so it's, I think it could be very easy to convey this message about code.
Sí, y bueno, también un poco la intención era como que desde nuestra parte tener una perspectiva también como decolonialista del código, ¿no? Tanto como por esta cuestión de lenguaje como por la situación, bueno, como por la posición geográfica de pues a dónde fuimos.
So we wanted to, during those workshops we developed 15 little exercises of some very, very small, basically hello world programming languages. But then we developed a little bit more, 2 of them, because we saw that they were engaging not only with the ideology of live coding, but also with the particular they were also critical about their particular locale or culture. So the first one is called La Calle, and it is based on slang, particular of neighborhoods in Lima. So Ivanka is going to talk a little bit about that language.
Hola, participé en el lenguaje de la calle necesariamente porque Luis me invitó a generar de una manera identitaria, poder trabajar con el lenguaje. Lo del estuary me pareció demasiado importante porque dentro de lo que están los patrones que existen en Tidal, uno podría mediante Haskell ejecutar y poder transformar un lenguaje y un sonido mediante una performance. Entonces, lo que yo entiendo es que mediante Haskell uno puede transformar los sonidos y generarle un propio patrón. Y este patrón uno puede generar una propia poética. Todos los programadores generan poética a la vez que están escribiendo. Entonces, estuary me parece de una forma muy dinámica para de esta forma salir de la parte del cual uno programa en inglés y ser aceptado por otros tipos de lenguaje de comunicación. La calle, personalmente, es un lugar como estar en la calle. En este caso es de Lima o Perú. Traté de crear un lenguaje en el cual los barrios populares intentan dialogar y generar lógicas que son percibidas por distintos estratos sociales. Entonces, mediante una sonorización, pensar en un adjetivo, un pronombre, un sustantivo, me parece importante porque de esta manera ellos pueden percibir, o cualquier persona de habla hispana puede percibir que existe, uno le está mandando un mensaje de todas maneras. No necesariamente puede ser el paje de la sonorización, sino uno también puede interactuar. Entonces, la visibilidad de entender que existe una identidad donde uno puede asumir o mandar de una forma, composiciones sonoras, también puede mandar mensajes que sean aceptados para todos. Estuary hace eso, que todos se sientan identificados y todos puedan siendo performáticamente interactuando con el público, tengan ese diálogo del que ejecuta y el que recibe el mensaje como como un ensamble de persuasión entre ambos. Entonces eso me interesó y es por eso que estoy acá.
And also, because of time constraint, maybe we can't translate what Ivanka was saying, but the full interview is on the paper, and I just realized that the paper is not available on the English version of the website, but if you go to the Spanish version, you can download the PDF and look more about what just Ivanka was telling us about this language. The other language is called SUSIX, and it's the logic behind that is it was developed by transfeminist people and also based on reggaeton lyrics. And Marianne is going to talk a little bit about that language.
I try to speak in Spanish and in English too. Bueno, Susi o XXX es un lenguaje que fue creado por como por unas chicas que, varias de ellas son artistas, DJs, músicas, y bueno, es La Chacala, María Juana, Carolina Velasco y Daniela Moreno. Algunas de ellas se asumen como activistas gordas, no binarias, etc. Y bueno, lo que ellas hicieron fue como un lenguaje en el que se apropiaran como de los insultos que contienen las letras de reggaetón, como en el canon de lo que podría ser el reggaetón convencional, que es sumamente violento y agresivo contra las mujeres. Entonces, a partir de la apropiación y de ver el objeto, o sea, como que estas canciones hacen parecer a la mujer como el objeto del deseo, más bien la ponen como el objeto del deseo. Entonces, como que en el lenguaje lo que hicieron era más bien trasladarlo de objeto a sujeto, y entonces cuando te asumes como sujeto es cuando te apropias de tu propio cuerpo y del placer que esto genera, y el vínculo con el reggaetón es como la cuestión corporal, del baile y de mover el culo, básicamente. Entonces, pues un poco este lenguaje estaba como inspirado en estas letras y tenían como la intención de poner a la gente a perrear, ¿no? Como hacer twerking, básicamente. Bueno, reggaeton is a gender is often associated with a misogyny and gender violence referent in both the lyrics and the visual representation of the music videos. In reggaeton, it's assumed the women are the object of desire and that be leaning back to the man during the dance, twerking. They are and enjoy dancing. They are being marginalized and objectified. However, the latter position obviates how a woman might also desire and enjoy dancing this way, while twerking in strongly erotic it proposed is not always sexual. It is when a woman chooses to twerk someone, it does not mean necessary she wants to have sex with that person. It's the appropriation of one's body, of the pleasure it can generate with dancing, with what matters in this case. Y bueno, el lenguaje tenía como en su estructura tres partes. Uno que era como para inicializar el sonido, el otro era el nombre del sample, bueno, más bien como para invocar samples, y el tercer como sí, y bueno, la otra parte de la sintaxis, la final, incluía como la transformación. Entonces, para inicializar, incluía palabras como putita, perrita, tusicaria, mala mujer, amorfada, gata fiera, torta golosa y feminasti. Entonces, cualquiera de estas frases las podías poner, y ya después, para invocar samples, estaba cómeme, a ver, permítame, sí, cómeme era Fire, bueno, el sample de Fire de Tidal. Dame, Bass 2, azótame, 808. Rómpeme era un bass de Gabber. Barre el piso, interpélame, encadéname, aborta. Y los transformadores era suave, slow, suave, suavecito, slow 2, duro, más, con flow, con el pelo, con la lengua, y al final, cuando así, bueno, un poco como lo que vieron en el performance, al final quedaban frases como feminasti, aborta, duro, duro, ¿no? O feminasti, dame con la lengua, o torta golosa, rómpeme suave, suavecito, ¿no? Entonces, como que, pues al final un poco sonoramente tal vez no llegaba como hasta a donde estaba propuesto, pero independientemente del resultado sonoro, al final sí había una contundencia en el mensaje, evidentemente político, transfeminista y bueno, también muy decolonizador.
Yes, and also in the paper you can go to the GitHub and see the translations or the parsing. We're about to finish. So during our trip to South America, where we were teaching these workshops and developing this language, an optional online survey was also made available to participants to complete. So this survey assessed the user experience when utilizing computer languages as a means of music creation. And the aim was to identify opinion about potential language constraints benefiting or harming the learning and use of these languages. So the survey results do suggest that participants related knowing English with learning a programming language. More than a half of the participants were comfortable with learning a computer language through manuals, video tutorials, and workshops in English. The rest mentioned that finding this information almost always in English limits and discourages their learning, and because they are not fluent in that language. So this survey has a very low sample rate that prevents larger conclusions. However, the fact that the survey respondents offered complex opinions on the relationship between natural language and musical programming languages suggests that there is more to be explored in the area of live coding, ESOLangs, or culturally situated live coding languages. So finally, we have as a conclusion these 3 points here. So for us, developing these languages or making this exercise was important as it puts in conversation knowledges from both the artists, programmers, local community, and the global live coding community. Also shifts the attention from command and control toward cultural expression and refusal, and also invites to avoid essentializing the artist programmer by thinking them as developer within the broader culture of computation. So basically, that's our presentation, and more information is on the paper. Thanks.
Thanks very much. I think we're out of time for questions, unfortunately. Unless there's one really burning one. Okay, Mariah, you've got the floor. Yeah, one from Mariah.
Meow, meow, meow.
Yeah, thanks. Very interesting work. I was wondering, especially because different languages are very good at expressing different concepts, which I think can be really interesting to expand, like musical ideas or programming ideas. Did any of these come up? That you were like, well, this we actually can't translate back to English into Tidal, for example, like just concepts that were not translatable.
Yeah, so I think that wasn't the case particularly during these workshops, because we encountered the degrees of experience with live coding was very different between the participants, and basically, from what I remember, most of them were not very experienced in live coding, so they were, or even music, so they were developing their concepts. Actually, what we tried was not to bias them by telling them, telling them where was the documentation for tidal cycles, because we didn't want them to reproduce tidal cycles. That wasn't the idea. So we were just saying to them to develop tried to develop a computational language or a language that described music. And so many of them were asking, well, or were saying, I actually don't know anything about music. So we were saying, but you know what, like, I think you know because you hear music every day. So just like in plain words, describe how you would like the sounds to be called and what type of transformations would you like to have in your language. So at the end, we didn't have that, we didn't encounter that particular case of translating or being not able to translate any like concepts from one language to another. But future work actually is more about, I think, that, which is, in my opinion, or I see it as functionalities. So I think we will be working more in terms of not only language, but what are the functionalities that people might want in their languages and that are particular to their culture. So it might be related to the concept, I think. And I think that maybe those functionalities wouldn't be translatable. And yeah, in many cases.
Thanks very much. This is really nice work. I really enjoy the idea of programming languages and natural languages becoming one. I think it's the future. So one more round of applause for this group and also all the great presentations. Thanks very much. So if we maybe have a 10-minute break and meet back here at 12:05, is that okay, Jesus? Yeah, okay, so 12:05, a quick comfort break. Hello. It's me again. So I'm going to talk about a project I did called Pattern and Code. So this was a artist in residence. So it's like a report. It's not research. It was for an exhibition in Sheffield, where I live. It's part of the Children's Media Conference that happens there. So the aim was to make an installation. The installation had two parts. One was about coding with knots, bits of string, and the second part was about drumming using code in a drumming circle. Rennick helped me with this. Thanks, Rennick. He already worked on a connection between drumming circles and live coding with Joanna, and it made sense for him to contribute. I don't think he'll be getting up. I'm not sure where he is. But, so this was in collaboration mainly with a year of primary school children in Sheffield. There were 60 of them. Originally, they were going to be 10 or 11. So I designed this project for 10-year-olds. In the end, they weren't available, unfortunately. So I ended up working with 8 and 9-year-olds, mostly 8-year-olds. So this was about hiding messages in knots. I think there are people from the Andes here who probably know a lot more about this practice than me, but it's a way of storing and sharing information, digital information, using a way of coding decimal numbers in string. So different kinds of knots represent different numbers from 1 to 10. And then you have tens, hundreds, thousands, just as in the system we generally use today. I don't want to spend too much time on this, but you can kind of see there's a relationship between Kipu and what the children came up with. It was very free-form. It was very difficult, actually. Many 8-year-olds don't know how to tie knots. I found out. Actually, my son is 10, and he's not very good at tying his shoelaces. We should have to scrap that from the archive, actually. He would be very cross for you. Actually, he's 11. So it was inspired by Kipu, Inca, generally used in the Inca period to administrate their empire. And so we spent a lot of time. First of all, to make Kipu, you have to make strands, and this involves tightening the twist in the string up to a certain point, folding in half, and then it kind of pings into this thicker bit of string, which is quite amazing the first time you do it. It kind of changes how you see string from then on. So the children were really into that. It took quite a long time. And then I talked about the different kind of knots, but I didn't, it was just inspired by Kipu. Some children worked out how to store letters using numbers, which is quite a nice concept for them to explore through textile. But I really wanted to introduce coding as something very textile, but also something very ancient. So it's not something, so it's something that has cultural meaning and is also something that's very human. And that's how it was exhibited in the end. They wrote little notes on saying what they encoded. Okay. It was things like my dogs, or my age, and some just wanted to keep their message secret. So it's like a form of encryption, which I thought was nice. And then the next thing was to do some live coding with them. I only had 1 hour with each group. Did 7 groups of 8. We filmed 3 groups in the end, due to parental permission and things like that. So we had some time to explore different approaches. This was over 2 days. But 1 hour with a group of children to introduce live coding, teach Tidal, and record a performance was quite a challenge, especially with 10-year-olds. And then when it turned out they were 8-year-olds, I didn't know what would happen. But actually, it worked really well. And in 2 of the 3 groups, I ended up recording 2 performances. This is just some slides I showed them. We talked about a drumming circle. Luckily, they'd already done a drumming circle workshop, so they totally knew what all that was about. I showed them a video of what an algrave looks like, and people talking about what it means to them, just like the first couple of minutes of this video, which happens to be a really nice introduction. The video is also based in Sheffield, so we could talk about this being a local activity. And we talked about high and low. In the end, I only gave them 2 samples each, a high sound and a low sound. They each had different samples, but they were just playing with high and low. That's what I settled with. To start with, I had all kinds of things like cards I was giving to them with bits of code they could connect together and type in, but in the end I realized that with 8 children playing at the same time, the simpler it is, the better the musical results. And this is what I told them. Don't touch a speaker. Be careful of the wires. Put your hand up if you get stuck and have fun. So this was an interactive thing where I was helping them going round as they went. There were a lot of wires, it was a mess. And you can see each one had quite a nice speaker. It was really quite loud. But an 8-channel rig in a way. So the actual effect in the room was really quite amazing. Right. And this is how it looked. This is how we recorded it from the top down. And then it was projected down onto the floor in the actual installation. So you could hear what they were hear the music they were making. You could see them typing, and also on the screen you could see it was replaying their keystrokes in real time. So yeah, I'll show you a bit more. The bits of Tidal I told them about. Well, first of all, I made Tidal simpler. So you don't have to type sound if you don't want to. So I told them things like, the more you type, the faster it goes. You can do this sort of thing. And so, of course, immediately they started doing this sort of thing. And I taught them how to do that. and added some extra keywords like faster, which makes it faster in speed and in terms of pitch, in terms of musical note. And some higher order things like every 3 faster. There are a few of these. So there's crunch, what is this, scratch? So you can kind of imagine 8 of those at the same time already. That was more than enough. So I did some demos, left some example code on the screen, and then they just had fun with it. So I can try and replay. Was it? No. Yeah, I've downloaded this one, so if I replay, no, I think it's play actually. 2. Okay. Has that worked? Oh, I forgot to start the sessions. I think, save some memory, sorry about this. Right, so I need start terms. Okay, where's that gone there? Okay. And then play session. Right. This unfortunately isn't in sync. I didn't have time to get it all in sync. Yeah, it won't be in sync, but you can kind of see what they're doing. So you get the idea that lots of things going on at the same time, but there's still this kind of shared pulse. And so all locked together nicely. I can play this just with the audio from the camera so you can get an idea. It's a bit faster in real life, actually. See them kind of look between each other's screens and copy each other. I think these two were collaborating quite heavily. This one was really keen on making maximum noise. I think an algo babe in making. Yeah, lots of peer learning going on. Hands going out, there's a syntax error. I expect. Got a bit of ball patch. Okay. And then the end. Getting ready to hit the halt, yeah. Oh, lovely. Wonderful. That was ace. Thank you. Very good. Right, so that was that. That's my, okay. Sorry, I haven't got enough memory to do both at the same time. So, yeah, it went really well, I thought. The children really enjoyed visiting the exhibition as well, especially standing on each other's heads. But also, yeah, it was nice of them to make our exhibition, I think. I'll just go to future plans. I'm involved with a project called the Institute of Everything, which is happening in another primary school in New York. So I'll be developing it more with them over 2 days. But longer term, I want to bring together these two activities into the same thing. Because Kipu is a very well-developed digital interface in a way. It has a nice interrelation between binary and decimal representations, and it's something very manipulative about it. You can very easily unhitch a strand and put it somewhere else. So I want to make something, an interface for Tidal using a Quipu-inspired interface. Because Tidal and programming languages in general do involve tree structures, syntax trees, sometimes represented with parenthesis. And this works very well for Kipu, which is also a tree structure, non-cyclic. You just have branches. So I have this plan to work with Dave Griffiths, if you get some time, to make something where you have these Kipu strands, have some way of representing not-like structures, and then connect them together in a way that they, still while being cheap to make, can communicate with each other to pass on the structure up to the main strand, so that it can represent a tidal pattern. Hopefully sometime this year. Be nice. I don't know. Okay, thanks very much.
Meow, meow. Any question? Thank you, Alex.
Thank you.
Here.
Thank you. Sometimes teaching kids to code using something like Minecraft, there will be some of the kids that are really happy just to use the simplified version, and then there's those others that really want to dig in and say, like, what's the real thing going on here? Did you get many kids like that where they wanted to sort of find out all the bells and whistles they could get with Tidal?
No, there wasn't enough time inside an hour to give them an idea of what's possible. I did work, also as part of the same project, I worked with 3 visually impaired older children, teenagers, and we had several days to work through Tidal, and I introduced more to them. But they, I think they were more interested in just finding simple things which they had for themselves. So they liked to have different ways of using Tidal. So it's not like they wanted to know everything. They just wanted to find a way of doing something different from the others and sort of developing their own ideas, which was nice. But I didn't show this as a way to learn to code. It was a way to make music. It was an art residency. So it didn't have any kind of restrictions in that way. It was really focused on, I told them to really focus on listening and listening to each other, I think, and just show them simple ways to, simple aspects. But it was the full title, so it's just it would be possible to do anything in this interface, but I just kept it simple. But it'd be nice to have hopefully in this next project I'll have longer, and it'd be interesting to see how they respond and how they want to learn more.
I do have a question. Okay. We were wondering which is the point in which maybe by simplifying the interface, maybe you reach a point in which the user get lost or stop seeing what is in the other, like down, for example, in the synthesis machine. So, like by simplifying a lot the interface, the user stops seeing what is happening in the code, no? Which is something that live coding always has been pushing, no? To show your screen, let us see what is happening. And this is a risk, no? With really high-level languages, for example, you stop seeing, no? What is happening, no? And if you use a really low-level language, like C or like Super Collider or C Sound, it's really difficult to start doing a performance. You need to write a lot of code, no? So it's interesting, no? This inflection point, no?
How much do you show, and where is the music, I suppose? Which level do you think the music's on? I suppose I don't have any worry about not showing the synthesis level, because for me, I don't do synthesis. I don't know how to do synthesis. I just do trigger sounds using patterns. And so even though Haskell is a very high-level language and Tidal is on top of that, I still feel that's kind of the base level for me. I guess it relates to what Kate was saying earlier about imperative versus declarative. The actual nuts and bolts about how something is happening might not be so relevant for what the result is. I could certainly argue against what I just said, but I think, I guess that would just be confusing for everyone. But I think for me, this interface that I got working for the children is now what I use all the time as well. So it was kind of a sort of collaborative design process, I suppose. And it's not about, I suppose you can't show everything, and it's just showing what is important for me, which is just my own interface. Anything else I'm not too worried about. Okay, any more?
Anyone?
No, okay.
Well, thank you.
Yeah, sure. Hello. Hello? Okay, that's good. Hi there. My name's Ryan. and I'm from the University of Leeds in the UK. And today I'm going to be talking about an interface I've designed called CodeBank that explores public and private working in live coding performance. So just to introduce myself to those of you who don't know me, I developed the live coding library Foxdot for the Python programming language in 2015. I've been playing with that for quite a while. I'm currently a PhD candidate researching collaborative interfaces for live coding, looking at different ways that live coders can interact with each other through code. As part of that, I developed the Troop live coding interface, which if you were at the Algarve last night, you would have seen me use. I'll talk a bit about that in a second. So CodeBank is an interface that gives performers a private workspace to use to work on their own sort of version of the code that the audience is seeing. There's a bit of a crude diagram of how it kind of looks. You have performers listening to code generating music on their laptops through headphones, but there's also another public version of the code running that is generating audio for an audience who don't look that enthusiastic about it right now, but oh well. So it sort of gives users a kind of a safety net for experimentation. That sort of goes against what a lot of people feel is important in live coding, but again, I'll discuss that a bit later on. I think for a lot of newcomers to live coding, the idea of starting from scratch and improvising everything is quite daunting. So this gives users a bit of a safety net to try out new ideas before playing it to an audience. And it also sort of attempts to improve the overall kind of quality of music. Again, that's an arguable point, but the idea is that sometimes in live coding you might feel that you might try something new and it might not sound good to you. You can do that without worrying about that disrupting the live performance. So before I get into that, I'll sort of talk a bit about background of collaboration in live coding. Obviously there is a lot of different ways to collaborate, and I'm not going to talk about them all because there's just so many and there's lots of good ones, but here's just a few different ones. Collaboration can happen sort of at the language level. Tidal cycles, for example, is really good for sharing time and synchronizing across a network. Impromptu uses sort of bulletin board tuple spaces for sharing data easily across a network. Now that we have a lot of browser-based environments, instant messaging as part of the live coding performance to communicate with your co-performers is very common, like with Jibber. And there are also performance systems that are designed specifically to facilitate interaction or different types of interaction in live coding. So again, there's loads of these, but I'll just talk about a couple of them. One of them is Extramuros, developed by David Ogborn and others, which has sort of, I guess, morphed into what is now Estuary, which we saw a bit earlier about. And that was a big influence on my research developing Troop. So this is Extramuros. Each performer gets a different text box which displays on a web page, and users can see what their co-performers are doing on their screen, which is really useful. And they can also go in and change their co-performers' code, and it's a really nice way of interacting. But I thought that there could still be a little bit more of a direct interaction between performers and their code, which prompted, among other reasons, to develop Troop, which is an interface that's quite similar to Google Docs in the style that you're all editing the same body of text together. Users are given a different colored font that sort of shows the changes made to the code by different users over time. You'll sort of start off, everyone working on their own little bit of code in separate colors, but by the end of the performance, you have this real mishmash of the different colors, and you can sort of see how the performers have interacted with the code that each other has written, which I think is really nice. This is quite, I would say, a public, well, live coding is quite a public way of performing, but this especially because everything you do is immediately seen and experienced by your co-performers and the audience, which can be a little bit daunting at times. And it sort of prompted me to think about other ways of thinking about interacting in live coding through the interface. So with Troop, we would often start and we would have these kind of juxtaposed ideas that would not really gel or sound too good when played together. So, especially when we tried something new, I wanted to develop something where we could try something new and experiment without sort of worrying about actually it making the whole performance sound bad, quote unquote. And there's some research that suggests that working separately as opposed to together, people can be more creative and come up with better and more ideas. And also, while researching digital music interface design, Fenkart and Brian Kins found that users with their own space to work in enjoyed themselves using the instrument more. They built like an interface, not for live coding, but for, I think it was MIDI-based music, where users either all worked completely publicly, you could see what everyone was doing all the time. They also had a version where they had a private workspace, and also a version they had a private workspace, but other performers could look at that workspace if they chose to explicitly. And they found that the second version users enjoyed more. And they suggested that splitting up working into public and private spaces should be a key design consideration in digital music interface design. So that's kind of the heart and soul of the motivation for this project. So it also takes some inspiration from the SuperCollider history class, which I believe is now the Republic tool for SuperCollider, in that rather than working on a single body of code like in Troop or more traditional live coding, performers pass around what's known as codelets, little chunks of code, different to the history class, which all performers generate sound from their laptop in different areas, well, when used by the group PowerBooks Unplugged anyhow. Each laptop generates audio for the audience. In CodeBank, there is a server which is generating audio for the audience, and then the client applications, which are used by the performers, they hear their version of the audio through headphones. And this way of working where there is this sort of like public repository of these codelets and clients with their own working version made me think a bit about version control, which is a popular way of collaborating in software development, software engineering, which is different to live coding, but we're still using similar sort of tools, programming languages. So that sort of similarity resonated with me, and I sort of built in some version control type functionality into the program, which I'll talk about in a second. And yeah, just to be clear, that you have to use an extra machine for performing, which can be a bit of a pain if you don't have a spare laptop lying around or a Raspberry Pi or something similar. So this is what the interface looks like. This isn't the current version of it. These aren't my most up-to-date slides. I had some technical issues, so shout out to Guy for letting me use his laptop and update my slides a bit. But this is basically what it looks like. At the top, labeled A, you have what is the public repository of code. Each one of these blocks is a codelet. The background color relates to the user who's just last updated it. You can see the users in the D on the left, on the right for you, that is. If a user wants to edit one of these codelets, they can click on it, and they then reserve it so that you can't have any conflicts. and that grades it out, so that means the top codelet there is being edited by the user, which has the orange color, as you might be able to see from the border around it. That's been made bigger in recent versions to make it clearer who is editing it. If a codelet gets submitted with errors, it will highlight in pink and red to sort of show that it needs attention to be fixed. Labeled B are sort of what I call the action buttons that let the user do certain things. So the first one is push, which is push the changes you've made to your code in the text editor at the bottom to the public repository. The solo button lets you isolate the bit of code that you're working on in your workspace. So if you just want to hear what you're working on and not in the context of the rest of the music. You can reset the changes you've made. If you don't like them, you can just undo them all. You can also roll back changes to go back to previous versions, like the history of a codelet, if you want to sort of go back to something someone else had done earlier in the performance. And you can also hide these codelets if they're no longer being used, and then also reintroduce hidden ones if you want to, again, go back and revisit those obsolete codelets. And you can stop the clock, which will just clear everything for everyone. So yeah, in the labeled C, that's the text box you use to edit code, and there's a console labeled E to give you information about the state of the program. This is what the audience sees. This is the server program. You can see it's very similar to the client application, except it doesn't have the button section. You don't have the action buttons, the code, text editor, or the console. In the current version, we have added a text interface, like a chat interface that users can type into to communicate with their co-performers, which you can actually see on the server application. We thought we'd try and make the communication between us quite clear to the audience, because they're not seeing the coding so much. They see maybe the change of the state of the program as it evolves, but not the keystrokes themselves. So we want to make that process quite clear to the audience. So we had our first performance with the system just last month in Sheffield at Axis Space, which is a great local charity there for supporting local artists. So I'll show a few minutes of it. Yeah. So I should say that I've been performing with a group that I formed called the Yorkshire Programming Ensemble. So that's us there performing. This was at a end of cycle party for the end of the year, sort of for Christmas. So we decided to make it kind of Christmas themed. And you can see Lucy in her elf hat there, getting into the spirit of things. You can also see that we are taking off our headphones, listening to the sound in the space, but then also using the headphones to be able to hear our change that we're making to the code. Hopefully, you should also be able to see the code, the codelets on the projected screen being edited, going to a gray color, sort of moving up and down depending on when they were last edited, so that things at the bottom are haven't been edited for the longest time. So maybe to look at editing them, it sort of tries to make you change code that maybe has been going for a long time. So talking to my collaborators about not necessarily that performance, about rehearsing with the tool, this is what one of them had to say. She said, "It changed the way I was interacting with the code in that I was being more thoughtful about the changes I was making, but consequently paying less attention to what you guys are doing, compared to using Troop, where I have a general awareness of what you're both up to. I think it slowed me down a bit, but also encouraged more significant changes rather than incremental ones. So it's definitely had an impact on how we were interacting with code and with each other via code." So again, this is just our first performance with the system, and it's quite hard to get together with people to reflect on performances over the Christmas period, so not had much chance to really dig into what was going on in the performance, but here's some early observations. The changes made to the music that the audience was hearing were infrequent, but much more meaningful to the sound, rather than incremental changes that were heard by the user and the audience at the same time. While this was quite, I think, good and musically, it did mean that as performers, you wouldn't get an indication of where your co-performers were going with the sound. When we used Troop, the incremental changes would usually give us an idea of what was going to happen next, and we would all sort of move there together to a sort of shared aesthetic goal. But here, sometimes someone would introduce something that would be very different to what you were expecting, and you'd have to react and adapt to that. Whether that's good or bad, it's early to say, but it's quite interesting. The private workspace gave us all a platform to experiment without the fear of kind of messing up or ruining what someone else was maybe working on, trying new things. It might sound terrible, but actually you don't have to worry. We can, not have to fear because the audience isn't hearing it. It's just us. We can reset those changes or maybe pursue the avenue of this strange-sounding experiment to find something that we think fits more aesthetically with what we're playing. However, this does create a possible disconnect between the performers. As I mentioned, you don't get an indication of where they're going with the music next, so that's one of the reasons why we decided to introduce the chat element, the IM element, to try and communicate a bit better and not feel so disconnected musically. So some discussion points. I felt that from listening back to the video, from the audience perspective, it felt more succinct. There was abrupt changes in the sense that there were significant changes to the music, but they all felt like they were quite meaningful and taking the music somewhere new, as opposed to maybe small changes slowly changing. It was more of large changes changing the overall arch of the music, but quite infrequently. The idea of a workspace safety net, I guess, goes against kind of the status quo of what many people think of live coding, the idea of embracing error, but I think it's always good to challenge traditions, and hopefully it means that maybe people who are newer to live coding might find this useful to get into improvising. I know a lot of people who will play for the first time will pre-prepare a lot of their code as opposed to improvise it from scratch. So hopefully this would mean they can have a little balance between the two. They can not have to worry about messing up when they improvise. It required more effort to use this tool than Troop. That was quite an effortless, slightly further away, effortless tool. Although you have this sort of freedom to come up with your own ideas in the private workspace, you do have to do a lot of concentrating on the sound, what other people are doing with the code and the chat and things like that. But I think in the long run, it might be worth it for more succinct musical performances, but that's to be seen. The interface itself might be quite unclear to the audience. I didn't talk too much to people in the audience after that performance. Just gonna move that. But those I did speak to they said they didn't know what was going on with the interface. That person themselves wasn't involved with coding or live coding. So for them, it's probably just as strange seeing someone doing a normal live coding set as this, but I'd be interested to see what your opinions are. So it might kind of obfuscate the processes that are going on, which again sort of goes against a lot of what live coding is about, this kind of open culture of sharing your code. But you can sort of see the code is being shared, the code that's actually making the music for the audience. So next steps for this tool. So far it only works with Foxdot, because it's all written in Python and I can import that very easily. But like with Troop, I'm planning on making this available to work with a number of different languages like Tidal Cycles, Super Collider, or Sonic Pi. So thank you very much for listening. Cheers.
I think we have time for a couple of questions and then the next presentation.
Hey Ryan, thanks for presenting that. I might be misunderstanding some of how this works, but so you're familiar with LLC, Jason Freeman's environment?
Mm-hmm.
So one of the things that was interesting about that paper is he found that even though people were submitting these things to like a shared repository, that in collaborative settings, people didn't actually go and use the little snippets that other people submitted. They kind of just stayed working on their own particular little parts of the piece without moving on to other snippets that people were submitting to the repository. Did you find that your tool helped encourage people to work on other people's code, or am I misunderstanding something about how the tool works?
Oh yeah, it's a good point. Yeah, I probably wasn't too clear about that, but yes, it was quite good in that being separate, you could be kind of more creative with your ideas, and then push that out into the public repository, and then we were pretty good at taking someone else's idea and then doing something interesting with that and playing around with it. So yeah, it did encourage us to use other people's codelets they were submitting to the public repository, which was good, except that often there was a feeling of kind of ownership. Whoever submitted it first, you don't want to sort of tread on their toes. That was their algorithm they wrote. I think we're still getting used to being able to, transform it completely and take it somewhere else, especially now we have the ability to roll back. We've not got quite good at changing those codelets in a very big way. But yeah, it was a good way to work on each other's ideas. If that's sure.
Maybe one more question before Chris and Tor. Anyone? Okay.
Thank you for your presentation. Wow, that was loud. So you were saying because they can work on their own code with their headphones, they get disconnected from the other performers while writing their code. Have you tried about making some kind of mixer system where you can actually listen to the other person through the headphone while performing, and maybe still listen to what the rest is doing and work on your code?
Yeah,
Wow.
that's an interesting idea, actually. Hadn't really thought about it, but yeah, maybe being able to switch between, because right now you work with your code in the context of what the audience is hearing, but if everyone's working at the same time, what everyone's working on might be quite different. So that's an interesting idea, actually. I will think about adding that. Thank you.
Cool.
That's cool.
Okay. Thank you very much.
Thank you.
And one last presentation.
So, hello. All right, hello everyone. This is Chris Kiefer and I'm Thor Magnusson, and we're from the Experimental Music Technologies Lab in Sussex. We're presenting a survey that we did as part of a project that we're running called Mimic. And this is a 3-year AHRC-funded research project that is a collaboration between Sussex, Durham, and Goldsmiths. And we have here Francisco, who's working with us at Sussex. He's still in Goldsmiths, but he's coming to Sussex. And somewhere here, maybe you have Shelley, yes, over there. And she is in Durham, working with Nick Collins on the machine listening part of the project. The project is really about applying machine listening and machine learning libraries and trying to provide these technologies to lay people or music producers, the kind of creative coders that are maybe not computer scientists, but would enjoy it and find useful to use these technologies in their musical creativity or artistic creativity in general. So we have these technologies that we find very interesting, and we want to package them for people to use. And what's the best way of doing that? Of course, creating a live coding language for people to experiment with, we think is a natural way of doing things. So the project, the Sussex part of the project, we could really say that Goldsmiths is doing the machine learning, Durham is doing the machine listening, and the three of us here at Sussex, we're going to be designing a live coding language for machine learning and listening. So we ran a survey, and we wanted to ask you people and other people in machine learning and machine listening communities what kind of language you would imagine to see to do live coding in a browser-based, JavaScript, kind of web-based systems. So that's really what we're presenting here today. We're presenting the results of this survey. So I guess, so we want to create a high-level language, and we want it to be a meta language where you guys can make your own versions, make your own languages to interface with these technologies.
So to just set the context, we're thinking about machine learning and how some recent innovations might be useful to people doing creative work. Things are moving really fast in machine learning. Is this not on?
There, that was it, I think. Yeah, I could
hear. Yeah, brilliant. Okay, yeah, so things are moving pretty fast in machine learning at the moment. So this is a kind of really rough idea of the things that might be interesting to people doing creative work. There's been a lot of development in generative modeling, so training models to generate sound, image, things like WaveNet, generative adversarial networks, pattern manipulation using RNNs and conceptors, for example. And we've got the Google Magenta project, which is putting out a lot of interesting work and models for artists to use to generate music. We've generally seen a better understanding of modeling time. So a while ago, neural networks tended to work on instantaneous data, but we've got a lot better at using recurrent networks that look at history of interaction. So obviously this is much better for musicians. We've seen a lot of improvements in deep learning techniques and classifiers for things like gesture. We've got meta-learning, which is training machines to train machines. And also, people are looking at workflow, so different ways to bring neural networks out of research institutions into the hands of artists. I think about interactive machine learning and user-friendly approaches like the Rapid Mix API?
So as I said, we're really interested in your views, and that's why we're running the survey. And that's something we want to explore further in the workshop today. We're going to have a workshop where we talk a little bit about machine learning, and we will do hands-on experiments with machine learning and live coding. But then afterwards, we're hoping to have an interesting discussion of what we would do with machine learning and live coding, and what kind of language we would want to see, what kind of language you want to have and work with. So we're hoping to see some of you there. There are, of course, great workshops at 4 p.m. today, but we hope to see some of you who are interested in machine learning in our workshop. The workshop will be run by Francisco and Chris and myself. So let's just go and start to look at the questionnaire now, because there were really interesting findings that came through, and we want to report a little bit to you what came out of it. Some of you probably did the survey. The survey is still open, so we still encourage you to help us to design these systems by filling it out. But the survey was an open study, so it was aimed at anyone who is interested in these things, not kind of experienced live coders necessarily, not necessarily language designers or machine listening. So anyone who's interested in this or has some kind of views about this could fill in the survey. We sent it all over, and we tried to get broad range of responses. The survey had open-ended answers, so a lot of qualitative questions where people would describe what they found, pros and cons of approaches and so on. We were trying to encourage people to come up with speculative and cutting-edge ideas rather than implementation details or examples of specific languages. And then we were trying to really pull information from people what they would want to see in a future live coding language. So the survey was split in two parts, compulsory section with fundamental questions, and then a longer section with more kind of free, qualitative, and optional questions.
So we advertised the survey on a variety of mailing lists, academic, industry mailing lists, artistic communities, also on social media. We had 47 participants so far, mostly in the 18 to 40 range. Interestingly, gender-wise, most respondents were male. So we're presenting these results with a caveat that they're not really representative of the gender diversity of our community. But the survey's still open, so we hope to collect some more diverse results. We asked people their roles, so we had a lot of musicians, artists, some people from industry, a large proportion of live coders, and we asked people about the languages they were using, so this is the list here, so kind of Python, JavaScript, C++, and some of the more artistically oriented languages like Tidal, MaxMSP. We asked people what their machine listening experience was, and so not much machine listening experience in the respondents. A bit more on the machine learning side, but still kind of not many experts there. And so the respondents, a lot of people had a lot of live coding experience. So that's the kind of balance of respondents.
So we're going to go quickly through just so we kind of get a feeling for what kind of feedback we were getting. You can read more about that in our paper, of course. But we're going to go through some of the questions. So we had a question of what are the high-level properties and features that you would look for in a programming language and why. So for live code, there's obviously brevity and expressiveness, consistency and readability are quite important. So you want to be high level, you want to talk with the machine and get the machine doing things through few commands, readable commands, and very expressive. the language should support your way of thinking, your mental models. So, and that's a dual kind of relationship, of course, because you learn them, you form your mental model from learning the language as well. But it's a little bit about how easy it is to build that relationship with the language, that kind of musical thought processes. Flexible data structures. People said that languages also support different ways of thinking. So some people want to apply object-oriented paradigms maybe in certain contexts and functional paradigms in others. And it's nice when the language is flexible for different ways of thinking about problems. And support the creation of new language constructs. That's an interesting thing. So you can create your own kind of higher level, maybe, representations or hooks into the language. Another question we had was, if you have live coded or used dynamical programming environments before, how does it benefit you and what do you use it for? So dynamic programming environments, we're talking here maybe more to the machine learning experts who maybe don't know what live coding means or it's unfamiliar to them. But people then replied that dynamic coding enables a method of sketching, thinking out loud in code, so bottom-up creativity where you shape your thoughts through shaping the program, and it's a conversation with the program, which is very different from sitting down with a pen and paper and designing an XML diagram or something, how everything is going to work. In the moment engagement, so people want to kind of be in the flow and kind of feel that they're progressing steadily without having too much problems. And for that reason, you know, a good help system and a good kind of example system is really good because you can quickly copy something from the help files like we do, for example, in SuperCollider. Live coding is not only a performance method, it's also a way of conversing with computers. So to explore ideas. It's not just to perform, it's a way of doing things, of trying things out, way of sketching, inventing. So this emergence, people often talked about the relationship with the language as something where something is emerging, something is building up, and it's really a conversation. That was something that came up in a lot of the answers. And live coding enables a different type of conversation than, you know, compiled languages. Like if you were to do something in C++ or something, you're not really conversing so much there. You're stopping and compiling and all that. So, yeah, enable different way of composition, performances. Temporal processes is something that people mentioned, that live coding enables you to think differently about time and experience time and be in time with the program, which is quite interesting. I think it's the third question here, what are the key features of programming languages or environments that enable you to achieve your objectives? So, of course, we're taking here the highlights of or answers that were quite common with people, and you have more details in our paper. But people talked about flexible languages that minimize unnecessary effort. Languages should be stable, portable, and expressive with good libraries and documentation. So we have, for example, a problem with SuperCollider that we cannot easily import libraries like a webcam or 3D 3D environments or whatever. Flexible dynamic structure, mixing programming paradigms, as I talked about earlier, to be able to use object-oriented and functional as you wish. And a lot of the live coding languages that we have do that, like SuperCollider can do that, JavaScript can do that, Lua. So people mentioned a lot that diverse paradigms are really helpful because you think differently with different languages, but that's not the only thing. You also think differently with different problems. So you might have a composition that has a certain character, and then the solutions that you come up with to solve the problems of the composition might be very specific to that particular piece. And then you write another piece or make another composition which is different, and you apply different paradigms. Then suddenly you might want to use object-oriented, whereas before you were doing something functional. What features of the language or environment help you to express complicated ideas? Please give examples. Flexibility, people talked about. Polymorphism is really useful, where people can kind of put in different arguments and they be interpreted differently depending on, for example, how many arguments there are that pass to the function. A clear inspection system to be able to understand what is going on in the black box of the program or in the functions. Malleable data structures that are adaptable to live coding processes, and code readability. So people talked about often how the difference of readability in object-oriented versus functional syntaxes. I guess that's very personal how people perceive that, but a lot of people, for example, complain about all the brackets in Scheme or Lisp or something, which is a functional language. And Lambda expressions for simplicity. I'm talking a lot here, but Chris is going to take all the next slides. I think, am I doing one more? You can just take
Yeah,
this.
sure. So we asked people what advice they give to novice programmers, because of course we're thinking about building this language as an entry level. So I think the highlight of that was thinking about practice-based learning approaches, which is quite a common thing in computer science, really. And of course, practicing regularly, thinking about maybe performative approaches to programming in that respect. We asked people what key features we should have in a language or environment to help to lower the bar of entry. So of course, error messages came up. This is an issue in some languages like SuperCollider processing, for example, that we need human-readable error messages. And I think probably the biggest thing was having a really good, well-documented library of help examples which people can learn from. And ways of visualizing complex data structures. And data structures are a thing that we have to really think about in machine learning, because things can get quite complex quite quickly. We asked people what are the key hindrances to novices when learning programming, so perhaps thinking about their own experience of when they started programming. And emotional factors came up as a big thing, so people building up a fear of programming, feeling intimidated or overwhelmed, having imposter syndrome. So we have to think about how we can help people to overcome that with new tools. And a lack of hybridity. So this would be maybe a programming language. Everyone has different learning styles. People have different programming styles. And the language has to be flexible enough to represent these different styles. I think we've got 2 more questions. So we asked if you were to design a live coding language from scratch, which features would you like? And we've got a really common theme here of hybridity, flexibility, so I'm thinking about malleable languages which can represent how people want to think individually. And of course, the key thing is thinking about time in terms of music, and brevity, so thinking about concise syntaxes which help people code performatively and quickly. And this was the last question. So what features would you like to see in a live coding language for machine learning, which is kind of really getting at the advice we'd like to get from the community about how we design our system. And the highlights of these results were this common theme of flexibility, malleability. Thinking about flexibility, also plugging anything into anything else. So can we connect patterns to music, to video? Can we make sure that this multimedia aspect is flexible? Can we integrate gesture really easily? Thinking about introspective methods, so kind of novel ways of seeing what's going on in the background to help people to program. Thinking about musicality and creativity as the priority of the design of the language. So really situating the language within creative work rather than engineering. And I think really interestingly, thinking about how to instrumentalize machine learning, so how to think of creating models in a musical way and how we could represent that process creatively, and indeed that being a kind of creative interface.
Great, so we have some time for discussion, but I think in the end, this survey was really interesting for us, and we're really grateful to everyone who filled it in, and we encourage those of you who haven't filled it in to maybe do it, because it's interesting to do it in order to find out about your own thoughts about these matters. It was really helpful, and there were a lot of interesting answers there that confirmed a lot of the things that we were thinking. There were perspectives that we hadn't thought of that were really helpful as well. There were some encouragements to take the language in certain ways, which is really nice. But we were kind of, we thought it was interesting that there was no paradigm shifting kind of new innovation. There was no mind-blowing kind of thing that came through, like someone suggesting a completely new paradigm of live coding and so on. But I think there is a reason for that, and many of you have those, are maybe working on those paradigm shifting, mind-blowing environments. But we understand that filling in a survey on an online kind of research project is not really the place where you introduce your mind-blowing, paradigm-shifting live coding language. So, so we kind of, we will wait and see what you guys are working on as well, to learn from you through practice and not through our survey here. We're still interested in your comments, you know, but it's natural that certain things are not presented in a survey. But yeah, is there anything more we want to discuss before we start to open it up?
We should open it up.
Yeah. So it would be nice really to hear about your views. So the survey is still running, but that's not going to be, we're not going to do any research on that anymore. We're going to just use it for our project, for our development of the project. So any further input into the survey is going to be really helpful. There's a question.
Yeah, there's a question.
Yeah, it just struck me that maybe thinking about design of a programming language in terms of its emotional impact is maybe quite a groundbreaking. It's quite a strange thing, isn't it? I don't know if many programming language designers think, right, what's the emotional impact of this?
That's right.
So maybe that kind of thing is actually giving you a new view on things. Maybe there's other things.
I think that's a really interesting, strong point. Yeah.
And also thinking about like people saying that community was really important. So how can you design a programming language and design a community around it, or how to bring community into that? The growth of the community is part of the design process. Not necessarily participatory design, but how do you design the growth of a community? Bootstrapping.
Yeah. Well, community comes from users, so I guess, I think many of us have experienced publishing live coding languages, and there are certain things that are important: help files, examples, a mailing list, a forum of some sort. Well, Alex, you're a master in these activities, of course, organizing activities and gatherings, workshops, and so on. That's how communities build up. And having a good humor and good spirit, and be polite with each other, and enjoy music. Yeah.
No, I think working with the wider live coding community from the start is a good way to establish that, and making sure people have got a stake in how things develop.
Maybe another quick question before the Alicia. Well, we have two. Let's.
Thanks. I'm just getting started looking at machine learning myself. And I have a question in terms of your maybe overarching aims for this project, in terms of whether you're looking at it as a way to bridge between live coding and some maybe multi-dimensional data system or data set. To make that data set more accessible to live coding practice, or maybe in the opposite, to give agency to the data set to generate code. And if you understand the sort of dichotomy there, maybe you can speak to, whether you see more opportunities coming from one side or the other, or if you're really trying to capture both of those directions.
Do you want to reply to that?
So I think generally what we're trying to do is, I'm not sure if it's going to answer completely, but move, try and bring machine learning out from kind of, the tools in machine learning at the moment are very oriented towards academic research. So we've got kind of Jupyter Notebooks, MATLAB, which is all kind of live programming in a way, but they're not very accessible to artists. So we're trying to bring the tools and the data sets kind of out front in an accessible way. I'm not completely sure if that answers that, but...
I also think people will have very different needs and wishes and aims with using this language. So we're basically trying to create the kind of framework or environment for people to do many of these things that you were, suggesting. So we try to keep it open and not to set any kind of design decisions too strict.
Hello. As you know, I've been playing around with machine learning for a while as well. I think one of the biggest challenges is to really get this flexibility, because with live coding you maybe don't know what the goal is yet. You're musicking in a way. And that's I think there's a tension there with a lot of the machine learning algorithms, where you have to predefine how many inputs you're using, how large, for example, your neural nets are, which is an indication of how much information they can contain. how many outputs you have, what classifications you are, and with live coding, if you want to live code that, you much more would want to have like an incremental approach where you say, well, let's see what this does with one input, and then, well, maybe I add another input to this, another like live stream of data that I input there, and maybe you're also classifying things on the fly, so you start with one classification and then another. So I think there's quite a big challenge there, which is interesting if that could happen.
Yeah, I agree. There are so many ways in which you can use machine learning as well. It could be that you are live coding and you want to apply some gestures as part of it, or that the machine learning is suggesting things that from the code that you're typing in, suggesting, continuation of of a code that you're writing, or that you have a dialogue between the system. Maybe there's an agency in the live coding language, and it's kind of improvising against you or with you, talking with you by suggesting things. Or it could be sound synthesis, that something is going on there. So it's at so many levels and so many different purposes that this can be used in, and I think we just want to keep it all open.
I think there is some real challenges there in terms of timescales, because in machine learning we can think about, you might set off a training process and it might finish a week later at one extreme, or we might be using a kind of interactively, iteratively training a model through examples, or we might be performing with a trained model. And those are all happening on different timescales. So how to mix those, I think, is a real challenge. It's something we've really got to think about.
Shame that we have to eat.
Oh yes,
it's really sad, but we
sorry
should
to
probably
keep you
eat.
Here.
No, but it's thank you, Tor and Chris. Thank you. And we finish with this presentation. This table. Please be on time here for the next session, which is going to be at 2:30. Thank you very much to everyone.